Let's talk about the idea of a stack, look at some examples, and then code this in or implement it in Python. So a stack is a pretty simple idea. It is a data structure, and it's a linear data structure, so it's kind of organized where if you were going to move through it, you'd move through it from one item to the next to the next. And it's a linear data structure that obeys the following principle. And the following principle is last in, first out. What this means is when we add items to the stack, we push them onto the stack. So let's start building a stack, and we'll say our stack is an empty list. So here's our stack. It's just an empty list, and we can only insert items by pushing them or remove them by popping them. And so let's start by pushing an item onto the stack, and let's say we push A. So now our stack just consists of A. And let's go ahead and push a couple other items onto the stack. So let's push B onto the stack. Now our stack consists of A and B. And the rightmost item here is considered the top of the stack. Another way of thinking about it is, let's say here's our stack, here's the top, here is A. Well, we first pushed A, and now on the top of the stack is B. Let's push one more item onto the stack. Let's push C. And so we're inserting C, and it's going to be inserted at the end of this list here. So our stack now is a B and then also C. And so C is the last item that we've added onto the stack. So let's just continue with our little vertical stack here. So remember, the insertion deletion is last in, first out. So the last item that we've added, which is C, will be the first item that we remove. So when we go to remove, that is pop items from the stack, our stack here, since the last item that we added was C, it will be the first item that we remove. So let's make sure that is B. Now when we go to pop again, pop an item, you guessed it, the last item that we added was B, and so that will be the first item that is removed. When we go to pop again, let's pop one more time. Well, now we're just going to have nothing in our stack because the last or most recent item that is existing in the stack is A, and so when we pop, we remove it. So the same thing would go through here for our vertical list. If we were to pop an item from our stack, C would go away. If we were to pop an item from the stack, B would go away, and then we would pop an item from a stack, it would be A. Now let's mention briefly some examples of stacks out in the real world. So a stack of plates might be one. You put one plate down, then another, then another. But when you remove the plates, you're always taking the plate on the top. That is, you're removing the most recently added plate. Another example would be a Pez dispenser. The way you load this thing is you add the candies, and as you add the candies, they kind of move downward. But when you remove the candies, you're always moving the one that's on top or the most recent one. So let's go ahead and implement this in Python. So let's call this stack Python implementation. And we'll create a class, and let's call the class stack. We'll need to initialize our stack, so we'll put def dunder init and self, and then we'll kind of call our stack this sort of initialization is data, and it will just be an empty list. Now, lists we can insert and delete on all kinds of locations and do lots of things with lists, but what we'll need to do are add some methods to our stack here so it obeys the push and pop methods. So we'll start with the push. What else do we need? So we're gonna take the stack and then add an element to it, some kind of item. Then we'll need a pop method, and for that we just need the list itself or the stack itself because we're just going to remove an item. And then the final thing that we'll want is just a way of printing the list. So this would be considered a secondary operation. This is not something we really need. So let's call this secondary operation, and let's call it print stack. And we just want to print the entire stack. So now that we have our three methods here, let's call these essential operations here. We will start with the push method. So with push, this is pretty simple. Since the underlying structure is the list, we could say self.data So this is our list up there, and we just need to append the element. And in doing this, it will add the item to the end of the list, which is considered the top for our purpose. So whenever we push something, so let's say we push, I don't know, A, this will get appended onto the list. So it'll be added to the right of the list, or the top. Now the thing that takes a little bit more work is the pop method. And so what we want to make sure we do here is say that if the length of our list is greater than 0, then we should be allowed to pop from the list. Because if it were 0, then we could not pop from the list. So what we want to return is, it's just self.data.pop. So this pop method on list actually removes the last item. So if we kind of hover over it, it says remove and return item at index. So the default is the last item in the list. But it'll give us an error if our list is empty. And then we want some kind of result if our list is empty. So let's just print something like stack is empty, cannot pop. So now that we have our structure built up, let's test this out a little bit. Oh, let's do the print stack. So for this, all we will really need is to, let's just say, print the list itself. Okay, so we have our stack, which consists of the push, which adds elements to the list, and the pop, which removes just the last element, or so the most recent item from the list. Let's go ahead and test all of this. So we'll start by initializing or instantiating the stack. And let's push a couple items onto the list. So let's just start with our list that we had before, which is A, B, and C, and then let's print the list. So print stack. So if we go ahead and run this, we see that our output here is A, B, and C. So this works perfectly. Now let's pop all these elements off. So let's pop each one off. And 1, 2, 3, and then we want to also print the stack at the end. Let's print it each time we pop it off. And so what we should get here is A and B, then we should get A, then we should get an empty list when we print it, and then let's do one more. This will illustrate our error message. And we want to go ahead and let's run the whole thing. And so here we have A and B, which is the printing of our initial list, our first pop, which gives us A and B. Then we have A, which is the second time we pop right here. Then we have the empty list, which is the third time. And so each time we're always removing the most recent element. And then when we finally try to pop from the list, we get our error message, which is the stack is empty. Let's look at one more. So rather than pushing strings to the list, let's push numbers. And let's just add in a bunch of numbers. So let's say for I in range, and let's just say 5. And for each one of these items, we want to push I to the list, and then let's print out the result. So print our stack. So let's go ahead and run this. So we get 0, 1, 2, 3, 4, and this is exactly right. So when we do this loop here, it'll start with 0, then 1, then 2, then 3, then 4. And so it's going to add each one of these to the list, and it's going to add it in this particular order. And so then we can pop items from the list. We could say, let's just pop 1, and we'll go ahead and print the stack. And so this should give us, since the last item was added was 4, we should have 0, 1, 2, and 3. And so when we print it, we get 0, 1, 2, and 3. So this is the basic idea of a stack data structure. We coded up some essential operations and a secondary operation. In the next video, we'll add to our class of the stack here, and with some additional secondary operations that uses a stack.